Hi students, welcome to AM Teachers Tech. My name is Lubna Afza. Today we are going to solve problems on chapter 1 real number, exercise 1.2. Check my previous video for exercise 1.1 on real number. The topic is here the fundamental theorem of arithmetic. Now before going this we should know what are prime numbers and what are natural numbers. So little bit we'll go through what is line number. So line number, if you see, this is your line number where you have negative numbers, 0 and positive numbers. Now all together negative numbers, 0 and positive numbers, we are calling it as integer. So integer contains -3, -2, -1, 0, 1, 2, 3 and many more. Okay, that is nothing but infinity. Okay, so this is called as integers where you have negative, 0 and positive. Next will come for the whole numbers. Whole numbers are such that it starts from 0. Now 0 and your positive numbers are your whole numbers. That is 0, 1, 2, 3 and 4 are your whole numbers. Okay. So next only positive numbers, that is from 1 to infinity, we are calling it as natural numbers. These are your natural numbers, that is 1, 2, 3, 4 and many more. So this is your natural numbers. Okay. So next we'll go for prime numbers. So what are prime numbers? Prime numbers are natural numbers that it has exactly two factors, that is 1 and itself. 1 and itself. For example, 2, 3, 5, 7, 11, 13, 17 and 19. For example, if I take 2 here, so 2 is divisible by 1. Okay, so 2 ones are 2, 0 remainder. Again 2 is also divisible by itself, that is 2 ones are 2, remainder is 0. So this, if you take 2, it is divisible by 1 or itself. Same way if I divide 3, so 3 is divisible by itself and 1. Same way it is 5 also. So the number which is divisible by itself and 1, then we are calling such number as prime number. Okay, so next we'll come for the composite number. Composite numbers are also natural numbers, so that has more than two factors. Like for example, if I take 4 here, 4, I have written here 4 here. So 4 is divisible by 1. Yes, it is divisible by 1. 4 ones are 4, so remainder is 0. Next, if I take 4, is it divisible by itself? Yes, it is divisible by itself. 4 ones are 4, again remainder is 0. Next, is it divisible by 2? Yes, it comes under the table of 2. So 4 twos are 4 and the remainder is 0. So you have how many factors you have for the 4? So for the 4 you have 1, then we have 2 and then we have 4. That means we have a factor more than 2. So that is third factor is also there. So this kind of numbers we are calling it as composite numbers. For example, 4, 6, 8, 10 and 12. So where we have more than two factors. Okay. So now we'll go for the exercise 1.2. 1.2. If you see here 1.2 exercise, question number 1 in this, express each number as a product of prime factor. So we have just gone through what are the prime numbers. So prime numbers are that numbers which is divisible by 1 and itself. So under question number 1, we have so many sub questions here, totally 5 we are there. So we'll try to solve as many possible today. Okay. So the question number 1 is question number 1. Okay, 104. So what we have to do, we have to do the prime factorization here. Prime factorization we'll start doing. This is your prime factor. What I'm doing is your factorization. Say 140, that is 14, is divisible in 7 table also, and it is divisible in 2 table also. Okay, you can start up from 7 also, you can start up from the 2 also. So I'll take a small number, that is 2. 2 sevens are, I will take down here 2. So next, it is again divisible by 2. It is again divisible by 2. 2 threes are 6. 1 is remainder, I will write it down here, so it becomes 10. 2 5s are 10. So next, it is divisible in table of 5, so 5 sevens are. If you see this 7 is a prime number. Okay, 7 is, what is 7? 7 is a prime number, so it is divisible by itself. 7 ones are. So I'll write down here 140. So 140, 2 into 2 into 5 into 7. Okay, so I can rewrite this equation as 2 to the power of 2 into 5 into 7. So these are the prime factor of number 140. Okay. Now I hope you know what is this. It is in the form of a to the power of b, something like this. So example, if I have 2 to the power of 4 means, that means 2 is multiplied 4 times. So the number 2 only is been multiplied by 4 times. So I will write down here. So how many times I will write? 2 into 2 into 2 into 2. So this is what is that mean. So 2 to the power of 4 is nothing but 2 into 2 into 2 into 2. So how many 2's I have here? I have 2 2's. So it has been multiplied by 2 times. So what I have written? 2 to the power of 2. Okay. So we'll go for the second problem here. Second problem, number 2. Number 2 is 156. Okay. So I'll use this notation. Okay. So it is 156. Okay. So we'll find the prime factor again here. I'll write a line here. This is factorization. I hope everyone knows factorization. What I'm doing is factorization. So I will start dividing this. So it is last number, if you see, it is a 6. Okay. So 6 is your even number. So if it is as the 6 last number is your even number, so whole number is even number. So this is divisible by 2. So 2 sevens are 14. So 1 I will take it. It becomes 16. 2 8s are 16. So again this is divisible by 2 as it is an even number. So 2 3s are 6. 1 is remainder. So I'm going to write it here. So 2 9s are 18. Yes. Okay. So 39 will get. So again if you see this 39 number, so this is divisible in 3. So 3 1s are 3 3s are. Now what is 13? What is 13? Yes, 13 is your prime number. So that means 13 ones are 13. So it is divisible by itself. So 156 you can write here. Prime factor of number 156 is equal to 2 into 2 into 3 into 13. Okay. So this is equal to 2 to the power of 2 into 3 into 13. Okay. So this is the answer. Okay. So we'll go for the third number. Third question number third. So that is 3825. Okay. So we'll try to find the prime factor of this number. It's a bigger number. 3825. Okay. So if you see this number, it is divisible by 5. Yes, it is divisible in 5, but it is also divisible in 3. 15. 3 5s are 15 you are going to get. So what will I do? I will divisible by 3. So 3 1s are 3 2s are 6. 6 means remainder is 2. You are going to get 2. It becomes 22. So 3 7s are 21. So 1 is remainder because 22 minus 21, 1 is remainder. So this becomes 15. 3 5s are 15. Okay. So next, which number is divisible? Again, it is divisible in 3. Yes, it is divisible in 3. So 3 4s are 12. 3 2s are 6. Yes, it is. Then how much is left out? 1 is remainder. So 7 minus 6 is 1. So 3 5s are 15. So 425. By seeing number only we can tell it is divisible in table of 5. So 5 8s are 40. Okay, so 5 8s are 40 means how much is remainder? It becomes 25. So 5 5s are 25. So 85. Again it is divisible in 5. So 5 1s are, how much is left out here? 3. 3 is remainder. So I'm going to write here 3. This becomes 35. 35 means 5 5 7s are. 5 7s are 35. So this becomes 17. So 17, what is 17? 17 is a prime number. So it is divisible by only 1. Okay. So that is 17 ones are 17. So next we'll write the prime factors here. Prime factors, factor of 3825 is 3 into 3, then 5 into 5 into 17. So I can rewrite it as 3 square into 5 square into 70. So these are the prime factor of 3825. Okay. So next we'll go for the next problem. So 4. Okay. So it is how much the next number is? 5550. 500. That is 5005. So we'll start factorization here. 5005. By seeing number only, we can tell it is divisible in 5. It is divisible in 5. So 5 ones are, okay, 0. I'll take this 0 down. So again 5 ones are. So again it is divisible. Is it divisible in 5? No, it is divisible. It is not divisible in 5. Last number is 1. That means it is divisible in 7. So 7 threes are, how much is left out? So 3 is left out. This becomes 30. Then 7 fours are how much? 28. 28 means how much is left out? 2. So 2 is remainder. So this becomes 21. 7 threes are 21. So this one is 1. This one is 1. 7 ones are. Okay, see 7. 7 ones are. 7 ones are 7. So how much is left? 3. So this becomes 30. 7 fours are 28. Then 21. So 7 threes are 21. Okay, fine. So this is the number. So now you have 143. So last number is 3. So you have to check the numbers. So which is, it will be divisible. So now this will be divisible by 11. So 11 ones are 11. So how much is left out here? Reminder. So 3. So this becomes 33. So 11 threes are 33 again. So 13 is a prime number. So it is divisible by itself. Okay. So the prime factor of 5005 is equal to 5 into 7 into 11 into 5. So the next problem is your fifth problem. This is 7429. So if we start factorizing this number, 7429. Now you have to look for the number to be factorized here. So you have to divide and see. You have to check out with almost all prime number, multiply and see. Okay. So next, so if you check this, so this is divisible by 17. So I will try to divide by 17 here. 7429. So 17 fours are 17 fours are. So how much it will be? 68. Okay, 68 if I write here. So if I subtract here one carrier, so 14 minus 6, 14 minus 8, you are going to get 6. I'm going to take this both the numbers down. So 2 9 29. So this becomes 629. See here it is 62 here. It is 62 here, but here it is you have 69. So you have to take a lesser number than 4. So what will I do? I will take 3. So 3 if I take 17 threes are 7 ones are 21. 2 is remainder, again 3 ones are 3, 3 4 5, so 51. So how much you are going to remainder? 1 1, and this becomes 9. Okay, fine. So the number what we are getting is 119. So you have to check with which number it's going to be divided again. So I'll try with 17 into 7, because last number is 9. So 7 sevens are 49. That's how I have assumed it should be 7. Okay, 7 sevens are, as 7 sevens are 49. So I have to get this number. So 7 sevens are 49. 9 4 is remainder, that is 4. I'm going to write it here up. So 7 ones are 7. 7 plus 4 is 11. So I have got this number. So that means it is divisible by 7. So 119. So remainder is 0. Okay. So please take down with me, all of you. Okay. So this one will be 17. 17 is 4 3 7. Okay. So next again you have to find out with which number it has been divisible. So I'll try up with the next prime number. So that is, I will try up with the 19. I'm going to try. So 19 4 3 7. Okay. So I will take it as, see, this is 42 43. So 43 means 19 twos are. So 19 twos are 43 means it's going to be 38. Okay. So if I subtract this, so this will be 13 minus 8. It will be 5. I'm going to take this 7 down. Okay. So the next number I'll take, because this is 38. 19 twos are 38. So I will take 19 threes are. So threes are 9 threes are 27. So 2 I'm going to write here. Again 3 ones are 3. 3 plus 5. 3 plus 2 5. Okay. So how much is the remainder? Remainder is 0. That means 19 23. So if you see this 23, so 23 is your prime number. So 23 is been divisible by itself. So 23 ones are. Okay. So the prime factor of 7429 is equal to 17 into 19 into 23. Okay, fine. So we'll go for the next problem, that is problem number 2. Okay, so this is the next problem, that is problem number 2. Find the LCM and HCF, LCM and HCF of the following pair of integer and verify LCM into HCF is equal to product of two number. So we'll take the under this problem we'll take the first problem, that is 26 and 91. Problem number 2 under this one. Okay, so it is 26 and 91. Okay, first we'll do the factorization for 26. So it is clearly divided by 2. So 2 ones are, 2 threes are. So 13 is a prime number, so it is divisible by itself, so 1. So the prime factor for 26, how do I write? 2 into 13. Okay, so next we will do factorization for 91. So 91, see, as the last number is 7, sorry 1, as the last number is 1 here, so it is divisible by 7. So 7 ones are 7, so how much is left out? 2 here, 2, it becomes 21. So 7 threes are 21. So that means again 13 is a prime number, so it is divisible by itself. So 91, how do I write? 91 is equal to 7 into 13. Okay, now first we have to write HCF. What is HCF? The full form of HCF is highest common factor. Its full form is highest common factor. It is nothing but product of smallest power of each common prime factor in the number. Okay, now if you see these two numbers, what is the common number here? 13. Okay, so 13. So what we will write, what is the HCF here? HCF is 13. Okay, so next we have to find out LCM. The full form of LCM is least common multiple. So that is nothing but we have to select the product of greatest power of each prime factor involved in the number. Now if you see here, if it is common, we will take the highest what is that power of that particular number, but we have the same power here also we have the same power, here also we have the same power. We have to take it only one time, so that is 13 into, and remaining numbers we have to write. So the remaining number is again into 2 into 7. So this is LCM. Now if you multiply these two numbers, how much we are going to get? So 7 twos are 14. So you have to multiply 14 into 13. So if you multiply these two number, 14 into 13. So 4 threes are 12, 1, 3 ones are 3, 3 plus 1, 4. Okay. So next 1 fours are 4 and 1 ones are 1. So how much you are going to get? 182. So you are going to get this 182. 182 is the LCM. Now next what we have to find out, LCM into HCF is equal to product of two numbers. Okay. So how much is LCM? LCM is 182 into how much is HCF? HCF is 13. So what are the two numbers we have taken? We have started as 26 into 91. Okay, now please multiply this. If you multiply, you are going to get it as 2336, and this also if you multiply, you are going to get 2330. So LHS is equal to RHS, so hence proved. Okay, so we'll go for the next problem here. Second problem number 2. It is 510 and 92. Okay, so first we'll do the prime factorization of 510. So 510, if you take, it is divisible into, yes, it is divisible into 2 twos are 4, so 1 is remainder, 2 fives are 1 is remainder, 2 fives are. So again this is divisible in which number? 2? No, it is divisible in 5. So 5 fives are 25, Okay, so 5 ones are. Okay, so next 51. 51 means it is divisible in 3. 3. Okay, so 3 ones are. Next, how much you are going to get here? 21. So 3 sevens are. Now if you take 17, 17 is your prime factor. It is divisible by itself, 1. Okay, so 510 is equal to 2 into 5 into 3 into 17. So this is uh, prime factor for 510. So now we will find out for 92. So 92 is easily divisible in 2. So 2 4s are 8. It becomes 12. 2 6 are. Okay. So next it is again divisible in 2. 2 2s are. 2 3s are. Okay. So 23, if you see, 23 is your prime number. So it is not divisible with any other number. So it is divisible by itself. So 23 once. So 92 could be written as 2 into 2 into 23. Now this could be also written as 2 to the power of 2 into 23. Now if you see, which is the common number here? Common number is 2. So HCF is equal to 2. Okay. LCM is equal to, see, we have to take the power here. So which is the greater power? So this one and this one common. Okay, so you have to take a greater power. So this one, so it becomes 2 to the power of 2, and the left out numbers, everything we have to write into 3 into 5 into 17 and into 23. Okay, so what are the numbers I have taken here? What all the numbers I have taken here? So uh, this is the power I have taken. So left out numbers is 3, 5, 17 and 23. Now multiply this number. So this becomes 4 into 3 into 5. So this becomes 4 3s are 12. 12 into 5 becomes 60. So it becomes 60 into 17 into 23. Okay, so into 17 into 23. Now if you multiply this number, how much you are going to get? You are going to get something to 23,460. Okay, now what you have to calculate? You have to calculate LCM into HCF is equal to product of two numbers. Okay, so LCM is how much? 23,460 into 2. Now what are the two numbers we have started with? 510 into 92. Okay, so if I multiply this, 2 zeros are 0, 2 6 are 12, 1 carrier, 2 4s are 8, 8 plus 1 9, 2 3s are 6, 2 4s are 2 2s are 4. So you're going to get this number. Now please multiply these two. I'm going to multiply with my calculators. Okay, so if you multiply, you're going to get the same number, 46,920. 2 ones are 2, 2 5s are 10. Okay, again 9 zeros are 0, 9 ones are 9, 9 5s are 45. Okay, so 0 2 9 6 4. Okay, are you getting the same number? Yes, we are getting the same number. Can you see? So hence proved, you can write hence verified, or you can write LHS is equal to RHS. Okay, so the next third problem we'll go for the third problem of your second question number 2. Okay, so it is 336 and 54. So first we'll try to find the factorization of 336. Is it divisible in 2? Yes, it is. But it is divisible correctly divisible in table of 3, because 3 3 6. Okay, so we'll take 3 only. So 3 1 1 2. Okay, so next it is divisible in 2. So 2 5s are 12, 2 6 are. Okay, again it is divisible in 2. So 2 2s are 4, 1 is remainder here, 2 8s are. Again it is divisible in 2. 2 1s are, 2 4s are. Again it is divisible in 2. 2 7s are. Okay, now if you see this 7 is your prime number, so it is divisible by itself. So I'll write down here, prime factor of 336 is equal to 3 into 2 into 2 into 2 into 2. How many 2's? 4. 1, 2, 3 and 4. Okay, so into 7. Okay, so this could be also written as 3 into 2 to the power of 4 into 7. Okay. Okay, so next we'll find the factorization for 54. 54, how do I write? So it is divisible. 54 into 2. So 2 2s are 4. So 2 7s are 27 means it is divisible in 3. So 3 9s are, again it is divisible in 3. 3 3s are, 3 is a prime number, so 3 1s are. So what will I write here? 54 is equal to 3 into 3 into 3 into 2. Okay, so how do I write here? 3 to the power of 3 into 2. Okay, now if you see, you have to check what are the common numbers. These number are common and this number are common. Correct, all of you? So I'll write it as HCF. Please write down with me, all of you. Okay, so 3 into 2, so this is 6. HCF how much? 6. Now we'll calculate LCM. Now this and this is common. We have to take the highest power. Highest power is how much? 3 to the power of 3. Okay, now this and this is common. We have to take the highest number power or greater power, you can tell. So this becomes 2 to the power of 4 into 7. Now how do I do this? This is 3 into 3 into 3 means how much? 27. Okay, into 2 into 2 into 2 into 2 means 2 2s are 4, 4 2s are 8, 8 2s are how much? 16. So into 16 into 7. So multiply this. I'll wait for a second, all of you. Multiply this and tell me the answer. So this is something equal to 3024. Okay. Now next step, what we have to do? We have to write LCM into HCF. LCM into HCF is equal to product of two numbers. That is 3024 into how much? 6. So this is equal to 336 into 54. So multiply these two. So how much you are going to get? 18144. And this also, if you multiply, you are going to get 18144. Hence verified or hence proved, or even you can write LHS is equal to RHS. Now we'll go for the problem number 3. Find the LCM and HCF of the following integer by applying the prime factorization method. Okay, so we have to apply the prime factorization method. So the first one is 12, 15 and 21. First one we'll take. We have under third question number 3. Again we have 3 problems. Okay, question number 3 in this one. Question number 1. So you have 12. What he has given is 12, 15 and 21. So we'll find the factorization of each number. So 12 is easily divisible into 2 6 are 12, again 2 3s are. 3 is what? 3 is a prime number, so 3 1s are 3. So first I will write down for 12. So 12 is 2 into 2 into 3. Okay, so this could be also written as 2 to the power of 2 into 3. Next we'll try to find out for 15. Okay, so 3 5s are, then 5 1s are, because 5 is your prime number. Okay, so it could be, it is divisible by itself. So for 15 we will write how much? 3 into 5. Okay, so the next one 21. Next number is so 3 7s are 21. So 7 is a prime number, so 7 1s are 7. So how do I write 21? 21 I'm going to write it as 3 into 7. Okay, so these 3 numbers we have taken. Now first we will calculate HCF. So HCF, you have to check for the common number. We have to check for the common number. So this is the common number here, 3 3 3 and 3. So that means HCF is 3. Next, what he has asked? He has asked for LCM. LCM is how much here? So we have to take the common number. Common number we have to write one time. So this is, I will write it as 3, and the left out number is 2 into 2 into 5 into 7. So 2 3s are how much? Multiply here. 2 3s are 6, 6 2s are 12, 12 into 5 is 60, 60 into 7 you do. So how much? 0. Multiply this, 7 zeros are 0, then 7 6 are 42. So LCM is 42. Okay. So we'll go for the next problem, second in under 3, question number 3, problem number 2. So numbers are 17, 23 and 29. Okay, so first we have to find the prime factors of these three numbers. Is it possible to find the prime factor of these three numbers? Is it divisible by any other number? 17 is divisible by any other number? Is 23 is divisible by any other number? Is 29 is divisible by any other number? No, it is not divisible by any other number. It is divisible by itself, or it is divisible by 1, because all three are prime numbers. 17 is a prime number, so I will just write 1 into 17. 23, how do I write? 1 into 23. 29, how do I write? 1 into 29. Why I am writing like this? Because it is not divisible by any other number. It is divisible by only 1 by 1 or by itself. So next, what we have to find out? We have to find out the HCF. So what is HCF? What is the common number here? So the common number is only 1 here. So HCF is equal to 1. Okay. The next is what? LCM we have to find out. So LCM is what? 1 into, left out numbers all we have to write down, 17 into 23 into 29. Now if I multiply these all three numbers, so how much I'm going to get? 11, 11, 339. Okay. So this is your LCM, that is 11,339. Okay. We'll go for the third problem. You can easily multiply this. Okay. So the third problem. Okay. So it is 8, 9 and 25. Okay. So 8 is divisible by 2, 4s are, then 2 2s are. 2 is a prime number, so it is divisible by 1. So 8, I'm going to write it down here. 8 is equal to 2 into 2 into 2. So that is nothing but how many times I can write? 2 to the power of 3. Next, 9 I will write 9. So 3 3s are, 3 1s are. Okay. So 9 is equal to 3 into 3 is equal to 3 to the power of 2. Next, 25. Okay. So 5 5s are, again 5 1s are. Okay. So 25, how do I write? 5 into 5. Okay. So that is 5 to the power of 2. Okay. Now what we have to find out first? We have to find out the HCF. HCF is any number is common here. Can you see here? You have 2 2 2 3 3 3 5 5 5 5 5. So no number is common. So what I can do? I can write it here something like into 1 into 1. You can write it down here also in the front. As I cannot write here, you please write down in the front. Okay. 1 into 1. So what is the common number here now? 1. Okay. So HCF is equal to 1. So what is LCM? LCM is equal to 2 to the power of 3 into 3 to the power of 2 into 5 to the power of square. Okay. So 3 into 3 into 3 is 8 into 2 into 2 into 2 is 8, and 3 into 3 is 9, and this one is 25. Okay. What is this? 8 9s are how much? 72. 72 into 25. Okay. So if you want, you can multiply this one. 72 into 25. So 5 2s are 10, 1 carrier. 35, 7 5s are 35 plus 1, 36. Again 2 2s are 4, 2 7s are 14. So 0, 10, 1 carrier. So this becomes 8, 1. So how much is LCM? LCM is 1800. Okay, so we have calculated HCF also and we have calculated LCM also. Okay, so we'll go for the next problem. So if you see this next problem here, the problem number 4. Okay, so 4, what is given? Given that HCF is equal to 306 and comma 657 is equal to 9. They have given two numbers, so they have already given HCF is equal to 9. Then find, he has told to you to find LCM and for the same number, that is 306 and 657. Okay, so we'll do it this problem number 4. What he has given, HCF is equal to 306 comma 657 is equal to 9. So what we have to find out, we have to calculate LCM of the same number. LCM of the same number. Okay, so how do we calculate this? Any idea? So till now in the problems we were using this formula. We know that, I will write down, we know that LCM into HCF for solving the problem, second problem number 2, we have used this formula. So this is equal to product of two given number, product of two given number or two numbers. So what we have to find out, we have to find out this one. So what will I do? I will remove this HCF. So if I remove if I take this HCF this side, so how do I write? So that will go into denominator. So LCM is equal to product of two numbers. So this HCF will go down. So HCF. So how much is, what is the product of two number? Which two numbers we have taken? So that is 306 into 657. What is HCF? HCF is 9. So if you multiply and then divide, it will be very bigger number, and what is that? It is very time consuming. So first what we'll do, I will first divide and then I will multiply. So it is easily divisible in table of 3. So 3 3s are 3 1s are 0. I will take 3 2s are. Again it is divisible in 3 tables. So 3 1s are 3 3s are 9. So 1 is left out, it becomes 12. So 3 4s are. So how much you are going to get here? 34 into 657. Now you multiply these two number. So if you multiply these two number, you are going to get it as LCM is equal to 22,338. Okay, so this is the value. Okay, so we'll go for the problem number 5 now. Problem number 5. Okay, so check whether 6 to the power of n can be end with digit 0 for any natural number n. Okay, so what he's telling, 6 to the power of n. So any number, if I substitute n is equal, this here is telling natural number. Natural number is what? 1 comma 2 comma 3 comma dash dash dash. So if I go on substituting the 6 to the power of n, so the number what I am getting, the last number should be equal to 0. Okay, so we'll try this. We are going to get this number or not, something else number we are getting or what we are getting. So we'll solve this problem. So that is problem number 5. I will read for problem number 5 one more time. Check whether 6 to the power of 1. See in the textbook, one more problem is solved same way. It is 4 to the power of n. You can just go through that. It is a solved problem in your textbook. Okay, you can go through that. It is the same problem and the same, almost same solution has been given there. Okay, so 6 to the power of n can be end with the digit 0 for any natural number n. Okay, so this is the problem. We'll try this problem. Okay, so first we'll write down natural numbers. Natural numbers, we know that. What is the natural numbers? 1, 2, 3, 4 and dash dash dash. Now see here, if I want any number to be in the form 0, if I want to get last number as 0, now it should be either in the table of 2. So because 2 5s are 10, or it should be in the table of 5. In 5 also, what will I get? I will get one time 5 and next I will get 0 if you properly see the table of 5. So it should be in the form of 2 to the power 2 into 5. See here, if I take this anything 0, so 1, if I take it here 1, so what will I get? 2 into 5, how much is 2 into 5? It is 10. So 10 to the power of 1, so what will I get? I will get 10. Again, if I have natural number, so 1, if I have substituted n is equal to 1 here. Next, if I substitute n is equal to 2 in this form, so 2 into 5 is to the power of 2. Okay, now what is 2 5s are 10, 10 to the power 10 square. So this is nothing but 10 into 10. So 10 into 10, what I'm going to get? I'm going to get 100. Again, when if I substitute n is equal to 3, natural numbers, here I have written natural numbers. Now I'm take n is equal to 3. N is equal to 3. If I substitute in this range 2 into 5, so to the power of 3. So what I'm going to get here? So that is nothing but 2 5s are 10 to the power of 3. So that is how do I write this? 10 into 10 into 10. So that is nothing but something 1000. Okay. So that means it should be in the range of, to get the last digit 0, it should be in the form of 2 into 5. It should be in the form of 2 into 5. Okay. So if you see this, if I find out the factorization of 6, if I find out the factorization of 6, what he has given? 6 to the power of n. So we'll first try to find out the factorization of 6. Okay, 6 3s are 3 is again prime number. So what you are going to get? You are going to get 2 into 3 to the power of n. So this could be written as 2 to the power of n into 3 to the power of, right. Even you can write in this form, or you can keep it like this only. Okay, both are same. Okay, so this is exponential formula. Okay, now if I substitute in this, see here, if I substitute n is equal to 1, so what will happen? So 6 2 into 3 to the power of 1. So what I'm going to get? 6 to the power of 1, that is nothing but 6. That means I'm not getting the last digit as 0. So one more value we will try. So 2 to the power of 2, n is equal to 2. So 2 into 3 to the power of 2. So that is nothing but 6 to the power of 2. Okay, that is nothing but 6 into 6. 6 6 are how much you are going to get? 36. That means any number, if you substitute n natural number, that is 1 2 3 to the power of, you are not going to get the last number as 0. So I have shown you for the n is equal to 1 and n is equal to 2. So if you want, you can verify with two more numbers. Okay, so you are not going to get the last digit as 0. So if you are not going to get last number as a digiter, that means what we have to write? Therefore 6 to the power of n cannot end with the digit 0 0 for any given, or any also you can write, if you want you can skip this given, any given natural numbers. Okay, so this is the solution of your question number 5. So we'll go for the question number 6. I hope you have understood this concept. Okay, so the one more problem, same way it has been solved in your textbook. You can just go through that problem also. Okay, so next is question number 6. We will take question number 6. Okay, explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. We have to check these two numbers or composite numbers or what. Okay, so we'll start doing question number 6. So I have told you when the starting of this class only, what is composite numbers. What are composite numbers? Composite numbers are natural numbers. This is also natural numbers. Okay, so which has more than two factors. Okay, prime numbers are numbers which has only two factors, but composite numbers are numbers which has more than two factors. Okay, so we'll start solving this. For example, if you want, we can see the 6 is a composite number or not. 6 is divisible by itself, 6 is also divisible by 1, it is also divisible by 2, it is also divisible by 3. So how many factors we have? 1, we have 2, we have 3, and we have 6. Okay, so how many factors we have? Totally we have 4 factors, which is more than 2 factors. So this kind of numbers we are calling it as a composite number. Okay, now what he has given here, so he has given 7 into 11 into 13 plus 30. Okay, now what you can do in this multiplication, there is one number 13, and after plus there is same number 13. So what you can do, you can multiply these numbers and then you can add, or what you can do, you can take a common factor of 13. So little bit one step of multiplication will be reduced. Both the ways you can do. Okay, but while doing, you have to so first you have to do multiplication, then you have to do addition. Okay, so two ways you can do. First you can multiply and then you can add, or what. So if I take a common factor here, 13, so this will be 7 into 11 into 1 plus 1. Okay, so next 13, 11s are 77, 77 into 1, again it is 77 plus 1. So this becomes 13 into 78. Okay, fine. So we'll find out the factorization of 78. 78 2s are 3, 1 carrier, 2 9s are 18. So this is divisible in 3, 3 1s are 3 3s are. Okay, so 13 is a prime factor, so it is divisible in itself, by itself, divisible by itself. So what are the factors? I'm going to write here factors. 13, so 2 comma 3, sorry, into 30 into 1. If you want, you can write it down 1 also. So these are the factors. Okay, so now if you see here, you have more than 2 factors. Now if you see this number, you have more than 2 factors. Therefore the given number, or you can write down the number only, or the given expression also, if you want, you can write given expression or given number. Okay, or given values. Okay, given number has factors of 1 comma 2 comma 3 and 13. Okay, hence the number is composite number. Okay, final of you. So the second number will go. So the second number in the same problem, he has given how much he has given. If you want, you can call expression also, or you can call it as a number also. So 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. Okay, now if you want, you can multiply the whole number and then you can add 5, or you can take a common here. Both the way, if you do, you are going to get the same result. So 7 into 6, 5 we have taken out, so into 1 into 4 into 3 into 2. Okay, into 1, if you want, you can write plus 1. Okay, now if I multiply this, 2 3s are 6, 6 4s are 24, 24 into 6, then you multiply with 7, so you are going to get it as how much you are going to get? 1008 plus 1. So this will be equal to 51009. Okay, so we'll find out the prime factors of this. So if you see this, if you want, you can find out the prime factor, or you can see that how many numbers we have. We have 5, we have 1009 you have, and one more value I can write it as 1 here. So directly I can write here the given number has the factor of 5 comma 1009 comma 1. So therefore the given number is a composite number. Last number is problem number 7. So there is a circular path. So either they are running or playing something, some kind of game they are doing. Okay, so there is a circular path around a sports field. Sonia takes 18 minutes to drive one complete round, like this, one complete round, Sonia. Okay, so one complete round, if this is Sonia. Okay, So this is the Sonia. Well, how much time she's taking? She's taking 18 minutes to complete. Now we have Ravi. While Ravi takes 12 minutes for the same, that means to complete the same path, what he's doing, he's taking how many minutes? He's taking 17 minutes. Sorry, 12 minutes. 12 minutes. Suppose they both start at the same point and at the same time. So that means they are starting at the same time and goes in the same direction. After how many minutes will they meet at the starting point? So this is the question. Okay, go through the problem one more time. So what he's telling, what is given in the problem? What is given in the problem? So problem number 7. So Sonia is there. Some girl called as Sonia. Now what is that? She's moving in the circular path. Okay, how much time she's taking? She's taking 18 minutes. Okay, so one more boy, Ravi. He's taking the same path, but he's completing in 12 minutes. Now suppose what he's telling, both are moving in the same direction. Okay, so both are moving in the same direction and they are starting on the same time. So at somewhere or some point, at the same point they will meet. Okay, so once they start moving from this round, okay, so after what time, what is the question, after what time or what minutes are they are going to meet at the same points? That means we have to calculate the least common multiple. What we have to calculate? We have to calculate the least common multiple. So Sonia is taking how many minutes? She's taking 18 minutes. Ravi is taking 12 minutes. Okay, so that means we have to calculate the multiple of 18 and multiple, what is the multiple of 18 and what is the least multiple? 12. So that means LCM of 18 comma 12. Okay, so first I will calculate the prime factorization, that is 18, 2s are 9, so 3 3s are 3 1s. Okay, so again for 12 if you calculate, for 12 2 6 2 3s are, then 3 1s. Okay, so I'll write down here for 18 it is 2 into 3 into 3. Okay, so that is nothing but 2 into 3 square. Okay, so 12 how do I write? 2 into 2 into 3, so that is 2 to the power of 2 into 3. Okay, so what we have to do, we have to check out with the numbers, common numbers. So we have to see these numbers. Okay, so these two numbers and these two numbers, we have to take the greatest power. So greatest power number is 2 to the power of 2 into 3 to the power of 2. So that means 2 2s are 4 into 9. Okay, so how much? 9 4s are 36. So they will take 36 minutes. They will take 36 minutes to meet at the same point. So therefore you write down one sentence. Also you have to write down they, or you can use both the names, that is Sonia and Ravi meet again at the starting point after 36. We have completed today exercise 1.2 of your chapter 1. I hope that you people have understood the explanation what I have given in this video. If you have understood the concept properly and clearly, so please subscribe, comment, like, and also click on the bell icon. See you in the next video. Thank you.